Welcome to the world of discrete electronics. Step into a realm where precision and creativity converge, where circuits come alive through individual components working in harmony. Discrete electronics is the art and science of crafting systems, using standalone elements like resistors, capacitors, diodes, inductors, and transistors. Let us build 1-watt LED for automotive applications. This simple circuit lets you run a 1-watt LED from the battery of your car. The ICMC 34063 is used here as a buck converter. It is a monolithic switching regulator subsystem, intended for use as a DC-DC converter. The device consists of an internal temperature-compensated reference, a comparator, a controlled duty cycle oscillator with an active current limit circuit, a driver, and a high current output switch. These functions are contained in an 8-pin dual inline package. Another major advantage of the switching regulator is that it allows increased application flexibility of the output voltage. IC1 MC34063. This is a versatile switching regulator IC that serves as the heart of the boost converter. It controls the switching of the power transistor, not explicitly shown in the diagram, to regulate the output voltage. R1, R2, these resistors set the feedback voltage for the IC34063, determining the output voltage. L1, 220 microhenries. This inductor stores energy during the switching cycle and releases it to boost the voltage. C1, 100 microfarads, C2, 470 pF, C3, 47 microfarads. These capacitors are used for filtering and smoothing the voltage. C1 is the input capacitor, C2 is for internal IC operation, and C3 is the output capacitor. D1, MBR2045. This diode is a fast recovery rectifier that prevents the current from flowing back to the inductor during the off time of the switching cycle. R3, 1K omega. This resistor is likely used to limit the current flowing through the feedback circuit. R4, 15 ohms. This resistor is likely used to limit the current flowing through the LED. LED1, 1W, white. This is the high-power LED that the circuit is designed to drive. S1, on-off switch. This switch controls the power to the circuit. Switching cycle. The IC34063 operates in a switching mode, turning the power transistor on and off at a high frequency. Charging phase. When the transistor is on, current flows from the battery through the inductor, charging it up. Discharging phase. When the transistor turns off, the inductor's stored energy is released, raising the voltage across the diode and powering the LED. Voltage regulation. The IC34063 constantly monitors the output voltage and adjusts the duty cycle, the ratio of on-time to off-time, of the transistor to maintain the desired output voltage. Stay tuned and keep learning. Subscribe to our YouTube channel www.codingscientist.com.